Part A. Use the rules of powers to show that x to the power 1/2 equals the square root of x. And here are the rules of powers. We are interested in these rules for a greater than 0 and for n and m being real numbers. We're going to prove this result in two slightly different ways. In the first approach, we will use the power of a power rule. And we consider x to the power of 1/2 squared, which by the power of a power rule becomes x to the power of 1/2 times 2, which is x to the power 1 on multiplying 1/2 by 2, which of course is simply x. And this gives us an equation involving x to the power 1/2, which we must solve. And indeed, we can extract x to the power 1/2 from x to the power 1/2 squared by taking the square root of both sides. And that works because the function f of x equals x squared and the function f of x equals the square root of x are mutually inverse functions, i.e. they undo the work of each other. And so we take the positive square root of both sides, which tells us that x to the power 1/2 equals the square root of x, as required. And note that here we can see the square root function and the square function acting as mutual inverses. In the second approach, we use the product of powers rule. We start with x to the half times x to the half, which becomes x to the power 1/2 plus 1/2 using the product of powers rule, which becomes x to the 1 on adding the halves, which becomes x. And now we note that x to the half times x to the half is x to the power 1/2 squared. And now we see that we have reproduced the result in part 1, and so we can finish the question in the same way by taking square roots. Part B. Expand fully x plus x to the minus 1 all squared. X plus x to the minus 1 all squared can be written as x plus 1 over x all squared, since x to the minus 1 equals 1 over x by the rules of powers. And we can write x plus 1 over x all squared as x plus 1 over x times x plus 1 over x, which we can FOIL out as follows. Which becomes x squared plus 1 plus 1 plus 1 over x squared, where 1 over x all squared becomes 1 over x squared by the application of this rule. A over b all squared equals a squared over b squared. And so finally we have x plus x to the minus 1 all squared equals x squared plus 2 plus 1 over x squared, or x squared plus 2 plus x to the minus 2. Part C. Hence write 123 and 1 over 121 to the power half as a mixed fraction. Since this question states hence, we must use either or both of the two previous parts of the question to answer this part. And we know from part B that x plus 1 over x squared equals x squared plus 2 plus 1 over x squared. But at the moment it's not clear what part B has to do with part C. We could ask the question, where is the power half? And also, where will a mixed fraction come from? Well, a mixed fraction is a whole number plus a fraction, and the squared quantity in the expression above looks suspiciously like a mixed fraction. And as for the power half, we could introduce one by taking the square root of both sides of the expression in question, which would produce this new expression. And we would then naturally want to equate these two expressions, like so. Now, at the moment, the left-hand side doesn't look very much like the right-hand side, but we can improve on that by splitting up the left-hand side as follows, where we have rewritten 123 as 121 plus 2. And now we have 3 terms on the left-hand side and 3 on the right, which we can equate as follows. And so we can see that we must set x squared equals 121, giving x equals 11. And now we substitute x equals 11 into the original expression to give 11 plus 1 over 11 all squared equals 121 plus 2 plus 1 over 121, which equals 123 and 1 over 121. And so we have that 11 and 1/11 squared equals 123 and 1 over 121. And so finally we take the square root of both sides to find that 123 and 1 over 121 to the power half equals 11 and 1/11, which is a mixed fraction, so we are done.